We go. Most of this should be review from last week, but a little refresher before the quiz when I'm back on Thursday on Boxplots. You're going to be taking notes on your handout. In a couple places, I'm going to ask you to stop and do the work and then check. You can restart the video and check and see how you did compared to what I had to say. Box plots are an important graph. I've already mentioned in class, they're the work of Tukey, and you know that makes me happy. What are some advantages of box plots? Well, the ease of construction. They're easy. It's a great way to show outliers. And in fact, by using the modified box plot on your calculator, you can tell without doing the calculation whether or not you have outliers. The construction is not subjective like histograms. Do you do 5 bins? Do you do 6? Should you do 10? That's a nice thing. And it's used with medium or large data sets. Small data sets like the baseball teams, not commonly used. And it's very useful when you want to compare two groups. So, like stem and leaf plots are great for that kind of comparison. When to use them? They're used for univariate numerical data, moderate to large. Less than 10, not a great way to look at data. So a skeleton box plot, you start by doing your 5-number summary, and you should know by now by heart, it's the min, Q1, the median, Q3, and the max. You draw your scale. Make sure you set it up to include the min and the max. Your spacing is even. Don't forget to label what it is you're graphing. So you label your axes. Construct your rectangular box from Q1 to Q3. Draw lines from the Q1 back down to your min and from Q3 to your max. You should draw a line in for your median. Oh, missed that, sorry. To describe, comment on the center, that's the median, the spread, that's the IQR, and the shape. And if there are any unusual features. Outliers. Here's data on the percentage of the population in a state and the District of Columbia of the proportion of the percentage of people in the state that have a bachelor's degree or higher in 2007. It's already been arranged from high to low. Okay. So take a minute, pause the video, and enter that data into your calculator and find your 5-number summary. Pause. All right, so you've got your 5-number summary. You set up your scale. It's going from 17 to 47, so it would make sense that your scale, labeled percentages, would go from 10 to 50. Draw your box from Q1 to Q3. Draw your line for the median. Draw your lines for your whiskers from the min to Q1, from Q3 to the max. And you're done. A modified box plot is used because it really points out those outliers. To display them, you have to identify them. And I told you the sneaky way is to enter your data into a list and display a modified box plot on your stat plot. And if there are dots there, you've got outliers. So the definition, it's a rule of thumb, is an observation is a mild outlier if it's more than 1.5 times the IQR away from the nearest quartile. So you find your IQR, multiply it by 1.5, and subtract it from Q1. You add it to Q3 to find how far away it is. It's an extreme outlier if it's 3 times the IQR away from the nearest quartile. So the same computation, but this time 3 times the IQR. That's pretty far from the bulk of your data, the middle 50%. The whiskers would go to the largest or smallest data observation that's not an outlier, and then you make your dots for your outliers. Generally preferred because they do tell you about those outliers. So here's the data again on percent with a bachelor's degree. Draw your scale, draw your box, draw your line for the median. Now, you need to find the fences for your outliers. How far are they going to be? So your IQR was 6. So 1.5 times 6, you subtract that from Q1, you get 15. You add it to 30, your Q3, to get 39. So any data points that are below 15 would be outliers on the lower end, and there aren't any. 17 is our smallest data value. Any data values above 39 are outliers at the high end, and we do have one data value, that's 47. By this definition, it is a mild outlier. Okay. Is 47 an extreme outlier? Well, multiply the IQR 6 times 3. Turns out that an extreme outlier would have to be 48 or larger. So it's not an extreme outlier. Put your solid dot for your outlier at 47. Draw your lines for the whiskers. Your lower line goes down to 17 to Q1. The upper line goes from Q3 at 30 all the way to 38, which is not an outlier, but it's our highest value that isn't an outlier. So to describe distribution for the percent of the population with a bachelor's degree or higher for the United States and the District of Columbia is positively skewed. It's skewed to the right. The tail is long on the right, with an outlier at 47%. The median is at 26% with an IQR of 6%. Here are 3 histograms for symmetrical data. You can see that their box plots look relatively similar. Can you tell the number of modes from a box plot? Pause the video and think about it. And the correct answer is no. No way to tell. Here I have a box plot that's approximately symmetrical, and you can see from the box plot that it's approximately symmetrical a little. It's a little bit skewed to the right. You can see the median is down, the tail stretches out longer in the box, but pretty close to being approximately symmetrical. Here's one that's definitely skewed. Okay. What I'd like you to do is look at these 5 box plots that compare the salaries of NBA players for these 5 teams. And I'd like you to write down how they compare based on the box plots. So pause, write down your comparisons, and then start the video. Pause. Don't cheat. Don't be a cheetah. I'll talk about this in class tomorrow.